Good evening or good afternoon, depending on what part of the world you're joining us from. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet monthly, typically every second week of the month. The meetings are free of charge and open to the public, so feel free to invite a friend, whether it's a hobbyist, a student, or another working professional. We cover a variety of topics related to Azure and infrastructure as a service, platform as a service, and of course, software as a service. You can find meeting information posted at the link at the bottom of the slide for both past as well as future meetings. One of the things that we always like to do is to thank our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes, which will be given away using the eval form. We'd also like to thank the .NET Foundation for sponsoring the Meetup site. And last but not least, NIS Technologies for sponsoring the virtual meeting space. In addition, we'd like to thank Manning.com for a 35% off offer on a selection of books with the link and the discount code that will be made available in the chat shortly after the presentation. So some general information. First and foremost, please keep in mind participation is always encouraged. And like I always say, the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And like I said, we want to keep it casual but organized, so feel free to jump in with questions. However, we want to give our presenter enough time to go through the slides and the demos. Lastly, the presentation is being recorded and will be posted on YouTube in just a few short days with the link posted in the chat window after the meeting. So for tonight's feature presentation, we have David Mauri from Microsoft, and he'll be discussing how to build a recommender using OpenAI. David is a product manager on the Azure SQL team. He's focusing on the developer experience, specifically working with Azure Data Platform MVP for 12 years. And he's also a full-time dad, and he joins us from Redmond, Washington. And so with that, David, welcome to the Azure Cleveland User Group.
Yeah, thank you so much. Thanks for having me here. Hopefully this is going to be interesting for everyone. I think it's a pretty hot topic today, vectors in AI and stuff. So let me start just about this presentation. So I can skip my presentation. Thanks, you already done it for me. So thank you. The goal of this presentation is to show you, and let me hide this little thing here, to show you how you can build something like the website that you can just go on right now and play around with it. And actually, let's do it together since I have the full screen already shared. So let's go to this website, ai.chicago.vslive.com. I've been in many Visual Studio conferences lately. And so just for fun, for exercise, for demo, I built this website where you can actually ask to the AI assistant here any session that you may want to attend. And let's say you don't know the agenda and you are just wondering if you want to go and attend to the VS Live that was done in Chicago like a month ago. Like, is there any session on, let's say, Python and AI? And let's see what happens. So what is going to happen is that vector search is going to be performed on the Azure SQL database, and we will, of course, discuss that in a few minutes. And then the result is passed to the LLM model, in this case, GPT 3.5 or 4 model. I don't remember what I choose for this specific demo. And what the model is able to do is basically consume the result of the session that has been found thanks to the vector search, and then basically give you a summary in a natural language format of what session you should go if you are interested in Python and AI. And not only you can get the answer, but you can also get the thoughts, or let's say whatever is similar to a thoughts that an LLM may have, that brought the LLM to give you this answer. And here, I think it's very nice, the website that we have built, because you can take exactly the same question, click on search, and actually let me zoom in even more, click on search instead of ask, and then exactly ask the same thing. And so you will be able to experience the difference between vector search, where you actually have a full kind of result with many sessions, all the sessions that are somehow similar, and then we'll also discuss what does it mean similarity in vector search terminology. Basically, all the sessions that are somehow related to this topic, so Python and AI, and you see there are many. And what you would normally do after doing vector search is that you should have to go through all the description and basically read them all and see if there is any that is basically aligned with what you're asking. And that shows the difference between just, in quote, just, because that is also already useful sometimes, vector search or similarity search, and RAG, or retrieval augmented generation, which is basically adding on top of vector search or similarity search also the generation part, which is basically moving the results to LLM and asking in natural language question and then getting back in natural language an answer. So this is what we want to build, and everything here it's already available on GitHub for you to use. So you can click on this little GitHub icon. Here you will be brought to the GitHub repository where you can find basically the working example. It's very easy to deploy on your Azure subscription, and there is a detailed explanation that, again, I will go through this explanation with you today. And basically the architecture, all the services used for building this solution that you can just deploy in your architecture in your subscription, and then maybe start to play with it, just adding maybe some few session as a test, or maybe then starting to change the session table with your own data and see what happens, and then you can start from there to build your own solution, your RAG solution on your own. So that's what we are going to build, or at least what we are going to analyze today. So again, AI.Chicago, there are many. I also did one for Las Vegas, and probably there are other few around, but they are all the same. The only thing that changes is the database behind the scene, or better, the content of the database. The database is always Azure SQL, of course. So how we do go from a table that has some data in it to this solution. So let's start. Let's go back to the slide and let's start with the foundation. So here I will go literally from scratch. We have still we have 1 hour, if I remember correctly, so still 45 minutes just to go over all the stuff, and it's more than enough to get a kickstart. So the first point that is important to understand is the word that is very widely used today, embeddings. Embeddings are nothing more than a numeric representation of some real-world subject or topic that the AI can do in order to represent something that we can define in words, images, text, description, even ideas into numbers, so that they can be manipulated by AI model. So embeddings, just to summarize, is a numeric, and more specifically is a not just one number, is a vector. So it's actually a sequence of number that represents something in AI mind, and that something is somehow related to the topic that we expressed and that we turned into embedding. So for example, here, if I go and type into some embedding model, the Foundation series by Isaac Asimov, then I will get these numbers back. Actually, there's a lot of numbers here, usually 1,500 more, and those numbers represents that concept. So a book, a series, science fiction, author, a person, Isaac Asimov, which is also a scientist. And so all these information are somehow captured by the embedding. Now, why embedding are important and why it's important that they are vectors? Because once you turn a concept into a number or a vector, you can immediately use math to actually understand if two concepts are similar. Now, when we discuss between humans, the concept of similarity is very subjective. Like for me, a book may be or not may be similar to a movie, but definitely is different than pizza, for example. We inherently know these differences, and we may disagree or agree on different level of similarity, but definitely we somehow internally automatically came up with this concept of similarity, or the opposite concept, distance, like how close to ideas or subjects are, or how distant they are. Now, thanks to math, we can do something a little bit more precise and calculate, given that at the end we transformed a concept into a sequence of number, into a vector, thanks to embedding, we can calculate how distant two concepts are, given that they are represented by numbers. There are many ways to calculate distance between vectors and thus embeddings. The most common one is what is called the angular distance, or more precisely, the cosine distance, that basically allows you to say, okay, I have generated the embedding that represents a dog. And this could be the embedding that represents a dog in terms of the image that you are seeing here, or a sound like barking, or even just a description of a dog. But those numbers, and so this vector, represent the dog in AI mind. Then I calculate, or I ask AI to calculate the embeddings for a cat, and then I get different numbers. Then I can use this math formula called cosine distance to basically take these two different vectors and see how close or how distant they are. And in this case, the cosine distance measures the angle between one vector and the other, because each vector, you can imagine that is just a pointer into a specific dimension. You can just calculate the angle between these two vectors, and basically the angle is 0, means that the two vectors absolutely overlaps, which means they are probably the same concept, or as close as the number is to 0, as close as the two concepts are to each other. Or if they are completely on the opposite side of things, you will have something like a higher number that represents the fact that you are far away from 0, and thus the two concepts are probably opposite or anyway distance between each other. So in this case, I used a common model to calculate embeddings, and then I calculate the cosine distance, and I see the cosine distance is 0.13, which it doesn't really mean anything, like 0.13 or 0.50 or 0.8. It's just a number that we take, and we say, okay, in AI mind, dog and cat are these ideas are of 0.13 distance between each other. Nice. We can use that to say, well, maybe I want to compare now this distance against another pair of vector. Let's say what happened. Let's calculate what happened if I compare a dog with a wolf. Well, ideally, the distance should be closer, because I guess dog and wolf are definitely closer in terms of in semantic term than dog and cat. And in fact, you can see that the cosine distance is a little bit smaller. It doesn't need to be much smaller. As long as it's smaller, then we can rank the result of our query vector. Let's say we are looking for dogs, and we have our database filled with information about animals. We just want to have the wolf appearing higher in our rank than cats, and then turtles, and then any other animal that you may want to compare against them. So that's exactly the importance of vectors and embeddings. Embeddings are nothing more than vectors just related to a human concept or to some concept and generated by an AI model. And that's why you probably want to take the text that you already have in your database. In my case, I took the title and the abstract of the sessions and turned that into a vector, because then once we turn that into a vector, we can start to search for similar concepts. And so, for example, I can search for all the sessions that are somehow similar to Python and AI. And I will get a list of all the sessions that somehow are similar to the topic I'm looking for. And this enables us to have more human-like question and answer, because we, for example, if I wouldn't use vector search, or if I couldn't use vector search, if I need to search for all the sessions that are somehow related to Python and AI, I will probably look for specific word in the session, right? But if our session is talking about Django and AI, well, Django is a Python framework. So in theory, I should still be able to find that session. But if I just use full text or any non-vector-based or similarity-based metrics for search, well, Django has no inherent similarity to Python unless we use embeddings, and thus embeddings and vectors to basically calculate these deals. So that's why I want to, first of all, start to take all the data that I have in my database, or that the user is providing as an input, turn it into an embedding so I can do similarity search. And that is the first step. But that is not enough, because again, similarity search returns everything that is similar to a concept, even those things that maybe are not on topic or related to the context I'm asking. Like, let's say I have a session of all kinds of conferences. So you could have IT conference like VS Live, or also chef conference where they talk about food. And if you are looking for something like duck typing, that is a common technique in Python, well, if you search only using vector search, you will get as a result session related to IT and session related to food. But of course, they are not something that they pertain to the same context, because if you are going to a IT conference, probably you don't really care about the duck in the sense of food. And that's why you want to do prompt engineering. So prompt engineering is the steps that you do when you take all the session out of the vector search, add context, so explain to the AI that you are providing it some sessions, and those sessions are about duck typing, and you are telling to the AI, well, you are an AI assistant that is helping me to choose a session for an IT conference, and you need to take a look at the session that I'm providing you and return to me the one that are most appropriate for me, that I'm interested in learning how to use duck typing in Python. Okay, with the session that will be returned by vector search, plus this additional context that you have provided, as I said, so in natural language, then the AI LLM can go through all the session that you provided, add the context, understand what sessions are applicable to the context and what are instead applicable to something else, so they are not of interest for you for this specific question, and then return in natural language the answer. So that's exactly what you've seen happening when I execute the query in the sample. And how all this architecture can be built in Azure today? Well, that's the kind of high-level architecture. So you have a client application. In my sample, the client application has been written in React. And then since I'm using a full stack, and more specifically a jump stack architecture here, and if you're not familiar with the terminology, jump stack means that my client application runs on the browser and communicates with the backend only with JSON. So my client application is only capable of calling basically a REST endpoint behind the scene, or a GraphQL endpoint, so my backend API. And the API will not provide a pre-rendered HTML in my case, but just JSON. And the JSON will actually be manipulated on the client to render the HTML. So that's exactly what's happening here. So let me highlight. So this is what's happening in my client application. And since I just said that my client application expects to communicate with REST or GraphQL and receive JSON as a response, then we need a backend that is able to take whatever query we want to send to the database and turn it into a REST or GraphQL endpoint. Now, typically, you would create this middle tier service, this backend. Typically, you would just implement a CRUD service, right? So you will be exposing a table, for example, the table of the session, or a storage procedure that allows you to specify some text to be searched. And you will be, opening the connection, executing the query, getting the results back, shipping it as JSON. But this is just the skeleton of the real functionality, because then you need to add pagination, sorting, filtering, not to mention authentication. And what happens if, since you're in the cloud, there is something going on and you can't reach database because maybe your node is being moved? Well, you need to have resiliency. You need to reconnect. You need to handle errors that maybe are temporary. So you need to do all this stuff. Luckily for you today, you don't have to build this solution. There is something called Data API Builder. It is an open source project that we just released in GA less than a month ago, that helps you to take any table, any view, or any storage procedure that you have in your database, and of course choose what of them you want to expose as a REST or GraphQL endpoint. So that's exactly what Data API Builder does for you. And once you have your database exposed as a REST endpoint or a GraphQL endpoint, the only thing you have to do is create a table, fill it with data, create a storage procedure to handle the search request, for example, and that's it. That's basically done. Your backend is completely done. Now, of course, you want to do something more interesting here, because what happens if you have your session table, and then I'll show you the session table in a second, but you have the session table, and of course, you want to start to convert the text that some backend person is providing you about the session, or even just the speaker adding their own session. And as soon as title and abstract of the session are saved in the database, what you want to do is fire off an execution to OpenAI, where your embedding model, your AI model is hosted, and turn that text into an embedding and save it into SQL. So one way to do that is using another technique called event-driven architecture, where you basically monitor the database for changes. And as soon as something has changed in the table, let's say the session table, that's what you want to monitor. As soon as a new row or a existing row is updated in the session table, you want to take the title and the abstract, and if those has been changed or just inserted, you want to pass them to OpenAI to calculate that embedding and store the embedding back in SQL. You can do that using something we call the Azure Function Trigger Binding, which is basically a function, so some C# code in my case. It could be Python, it could be Java, it could be JavaScript, that you can actually run in Azure and ask it to monitor a database for changes. And basically every time the database is changed, the function will be executed for you automatically. And the function will actually be calling OpenAI here, and again, turning your text into a vector, sending it into SQL, and then allowing the developers, and the users to execute a vector query. Now, this is the detailed architecture. Is just a little bit more complicated because in reality, we need to split this function in two. One function is the one that is actually monitoring the database for changes, and is the one that is actually converting that title and abstract into embeddings. And then we have another one that is just instead taking the request from the user, executing the similarity search, getting the result back as a form of a result set, and then taking the result set, adding the prompt engineering that I mentioned before, sending it to OpenAI again, so that now it sends a natural language query, so that OpenAI can crunch the numbers, return a natural language answer, and take the answer and display it on the client. So that's the only additional complexity. The function is actually split in two pieces, but ideally we just have one logical function. If you prefer containers, since here I used everything that I could on the serverless side, so I'm also using Static Web App to host the client and the backend. Static Web App is a Azure service that allows you to host your front end, your backend, and even the database connection, so to expose database as a GraphQL or REST endpoint, and everything run in Azure as a serverless approach. So you don't have to worry about containers or setting up infrastructure. That's what I like typically to do, but many developers prefer containers because they are more portable. They can run even easily on premises. So everything I just said can also work in a container, because everything that I used can also be executed in a container. Data API Builder is an open source project, I said, that is integrated with Azure, but is also available as an offline application. Your client application, of course, can run in any container, because .NET can run in any container. Your service that does the prompt engineering is just a C# service here, so again, can work in any container where .NET works, and the same as the service that monitors database, because the function that has this trigger kind of capability is actually using something that is available in Azure SQL and SQL Server that is called change tracking. That is a feature embedded in the engine that allows you to ask for only the changes happened on a table from the last time you queried it, for example. So it's something that can be easily implemented manually in a C# service. It's just a few lines of code. Of course, it's better if the function takes care of that for us. But again, everything can be done also in a container. And then, of course, SQL database can run in Azure as a SQL database or on premises like SQL Server. So just to summarize, and before moving to the code, for the front end, we will be using Static Web Apps, and specifically the front end is React. Everything will be communicating with the backend using a JSON request. The JSON request are handled by a tool called Data API Builder that takes your request and basically direct and rewrite the request to the database. So at the end of the day, you really are exposing table views and storage procedure as a REST endpoint. The chat handler, the one that does prompt engineering, is an Azure function. And the vectorizer, so the code that takes your text, existing text and existing abstract, and turn it into an embedding or a vector is basically an Azure function. As a database, you can use the free tier. Free tier is something we released a few months ago, and it means you really have an Azure SQL database for free forever. There can only be one per subscription, and of course there is some limitations in terms of how many CPU and how much resource do you get, but it's actually very good for this kind of startup project. And in one of the questions I usually get at this time is, okay, this is all nice, but is this scalable? Like if I deploy this solution in my project, can it scale up and out as much as I need? Because maybe I'm a big e-commerce shop and I need to handle hundreds of thousands or even million requests. Well, the answer is yes, because everything here is scalable by definition. We have static web apps that is completely serverless and fully stateless. So you can just scale and create as many front end as you want. Data API Builder is the same. It's a .NET application, fully stateless. So if you need more power, you just spin up more Data API Builder and just they will handle any workload you throw at them. Same goes for functions, serverless, fully stateless, so can scale out very nicely. Of course, database cannot be stateless by definition, but luckily we have hyperscale that can scale up to 100 terabyte of space if you really need that much space, and 80 vCore, so I would say plenty of power here. But even if that is not enough, since the majority of the work here will be reading and searching, we can easily also scale out up to 30 read-only replicas. Each one of those can have 80 vCore, so you can have a lot of power also on the hyperscale side, and it means that we are good. You can pretty much sustain any reasonable workload here that you want to throw at it. Just scale up and out and you'll be done. The architecture is also very flexible if you add more stuff or you want to change it, because we are just using a completely full stack Jamstack architecture, which means database backend and the front end are very well defined and isolated, and communication between each other layer happens using JSON or SQL execution. We also have a touch of event-driven architecture, because we have an Azure function that is actually monitoring the database and waiting for changes to happen in a very event-driven fashion. And in general, it's very easy to add more services if you want to add more support for more function or just extend it, because again, everything is very well isolated and basically communicate with other services in a very well-defined interface. Now, one thing that I want to highlight also is that at the moment, we are in the sample, it is using purely SQL Server and Azure SQL. That at the time I created this example, didn't have any vector support, any native vector support. But as said before, vector is just a sequence of number. Actually, is an ordered set of number. That's a vector. And an ordered set of number can be very nicely stored already in a table, where you actually store one value per row. And by doing that, if you apply a column store on a vector stored in such way, you also have the benefit of a column store that also has several internal applications to speed up calculation on vectors. So it works very well. If you don't have a huge amount of vectors, like you are in the 100,000 sort of ballpark, you can easily use already right now SQL Server and Azure SQL as vector databases. And as a proof of that, exactly the same application has been used for the .NET 2003 conference, where we had several thousand of people online at the same time querying the database, making a search on the stored session, and everything worked perfectly. And as you can see, the average time for vector search was 29 milliseconds. The message here is don't wait to start to explore vectors, because even today, even if you don't want to use or cannot use another database to store vector natively, you can just use SQL Server and Azure SQL. Now, of course, we know that storing vectors in a native way would be better, so we are working on it, and we just have announced vector support, but that's something that I will show you later. The other thing I want to highlight is how flexible is the solution, because the first version of the solution didn't have the RAG part, didn't have the retrieval augmented generation part. A friend of mine, Aaron Powell, added the RAG part and actually rewrote completely the UI without changing the database and all the backend. It's very, very easy to update and extend and apply to your use case. And again, Aaron just took like a few days to basically do. The majority was UX rework to make it nicer, and using React. I think I was using Vue at the beginning. Now let's deep dive into that right now. Before switching to the code, let me see if there are any questions. Let's switch to the.
I have a question for you, David.
Okay. Yep.
So when you're talking about embeddings, and the first slide that you showed for the embeddings, there were 6 words there. Is it safe to say that it's 1 vector per word?
That's interesting. No, it's a little bit more complicated than that. So basically, you can throw any text at the AI model, and they will generate 1 vector, and the vector is always the same length. So the vector is always in the most common case, 1536 dimension. So you have a 1 vector with 1536 vectors. Now, but that raises a good question, because of course, if I specify dog and I have a vector of 5536 dimension, or if I write the entire I don't know, SQL Server documentation, I still get 1 vector. So the problem now is how closely that vector represents such complex concept. Because if it's a dog, it's very easy. But if it's the entire SQL Server documentation, well, there are many concepts in there: high availability, clustering, AI. So how come a single vector can represent all of those? Well, that's where you start to have some challenges. The AI will try to do their best. It's best to basically create a vector that represents as many topics as there are in the text that you've provided, but of course, it's limited. So what you want to do, if you have very long text or a lot of text, you want to chunk the text in smaller pieces, let's say 1 sentence each, and then you create 1 embedding per sentence. And of course, in the database, then you will have a one-to-many relationship, basically, where you have your text and then many rows, so many embeddings that represents different aspects of those texts. Make sense?
Yes, absolutely. Thank you. Also, another question, if I may. So
yeah, sure.
When you were showing the 2 images between the cat and the dog,
yeah,
and likewise the 2 dogs, let's say that there's a vector difference of 0.12. Does it matter if it's 0.12 or negative 0.12?
It depends on the distance metric you are using. With the cosine distance, everything is recalculated, so it goes from 0 to 2. You know that 2 is completely the opposite of your topic or your idea. 0 is the same. There are other metrics that has different meaning. Usually, if you go in each database documentation, and we are actually building documentation right now, we document what are the meaning of each metric. So cosine is one metric. Other metric is the Euclidean distance. There is the Manhattan distance. There are many distances. Each one has a little different meaning. In general, all distances are built such in a way that closer to zero means more similarity. Let me share again my screen, and I can go to the blogs. And before going to the demo here, I also want to show that we just added support for vector native vector functions. So here there is explanation of basically many of the things that I mentioned, but now you can just vector. You have the vector distance that allows you to calculate embeddings. Embeddings looks like this one, like you have the text, and here you have the vector, and then you can just do here vector distance, and you can just calculate the distance specifying any of the metric, and depending on the metric itself, you have different number. But again, zero means equal or the same concept. Higher number, again, you usually don't really care about the number. It's more like a way for you to order them so that closer to zero means more similar.
I see. So okay. You need to be concerned with the sign of the value, whether it's positive or negative. You don't just look at the absolute value of that vector difference.
For example, there are some metrics that would require you to do so. In general, I would say the closer to zero in the distance, we try to build them so that they can't be negative. So this is called the negative dot product, which is actually true, but it turns out to be a positive number. But the closer to zero or the smallest generally is a positive number, but the smallest is the most similar. Now, the dot product is really not a distance. That's why it has this weird behavior. But for example, cosine and Euclidean, they can't go below zero.
I see. Yeah. Okay, thank you. Also, would you mind sharing that link in the chat window?
Absolutely. That's what I'm doing right now. And here we go. Okay. Let me go to code here, and zoom a bit. So, yep. So in the session recommender session. Okay. And let me open code, and we can start to see the project. And so you will see a lot of folders here. Let me go over each one of those, and then we get into the interesting part of the code, I think. Let me wait for VS Studio Code to start so I can nicely zoom in. And come on. Okay. That should be, still activating extension. But let's start taking a look at the folders here. So there are many folders, but the most important one is the client, is where you actually have the front end. So let me say 130. Okay. If you are familiar with the front end in React, let me show you. Well, first of all, this is the page that we are building. So we have like this is a single page application. So we have like several routes, one for handling the ask, the search, and of course also the about. But let's go into the source. Let's go to the pages. Let's go to, for example, search. And the search here, this is the input box. And the input box is using this button. And if I go and take a look at what the button is doing, you will see that it's getting the session. And get session is something you can find in API session. And this is basically what we do to get the session. So get session, we pass the content. So the content that you type here is basically the input of this get session function, and is passed to endpoint. So the front end doesn't know anything about the database. It just call an endpoint, passing the text in the body. That's it. Now let's take a look at how we create this endpoint, this find endpoint. And interesting, there is no code. You will not find any code here that basically implements that, because even if you go in the function, you see that the function, there is the chat handler. So this part will somehow handle this ask here, because we need to enrich the result with natural language request. But for the search, there is literally nothing. There is a session processor. Session processor is the code that is used in the backend to monitor a table and update the title and the abstract to get embeddings. So we'll take a look at this later, but there is no code here to handle that find endpoint. And the reason is very simple. It's because since we are deploying everything with static web apps, we can use a Data API Builder that is embedded in Static Web App. And Data API Builder, if you haven't used it, I really recommend you to take a look. Is this open source project where basically you give it a configuration file and a database, and then basically it will figure out automatically that the table that you specified, or the view, or the storage procedure needs to be exposed as a REST endpoint or a graphical endpoint. And how it does that? Well, it's very easy. There is a configuration file. So I click on the configuration file, and basically you specify the environment variable where you have the connection string saved, then some runtime information like where the REST endpoint will be made available. Since you have both REST and GraphQL, you probably want to have two different paths here. Other stuff that I will not go into detail right now, but then here's the interesting part. We are saying take this storage procedure web.findSession, and those are the parameters that will be provided by default if no parameters are specified, and expose it at the /find subpath under the REST path in answer to post request. That's it. That's how you take a storage procedure and expose it. Now the same way we can also expose for example, another storage procedure to get the session count, but we could also expose the session table. So here I'm exposing the entire session table, and I'm saying that it will be available at the /session path, and anyone, even if there is no authentication, well, anyone can just not authenticate, can just read. If you want to update or delete or do anything else that is changing the data of the session, you need to provide authentication as a form of JOT token. So that's very easy, because it means that my session are immediately available. And again, I don't have to write any code, only configuration code. And how do you create this JSON file? Well, of course, you can write it on your own. The schema is documented, but otherwise there is a tool, here it is, that comes as part of Data API Builder, which is DAB. And for example, I have the latest version here, DAB version. The latest version is 1.1.7, we just released, and allows you to just run Data API Builder, or you can do, let me clean again. For example, let's say I want to add the set. I already added, but what I've done in the past is DAB add session and basically this is how you actually add a session table to the configuration file. So you want to specify just a moniker, a name, the source of your the database object, in this case a table, what permission, and what is the REST path at which this session should be exposed. That's it. It will automatically update the JSON file for you, and you're done. So it's very nice. Then if you want to run Data API Builder locally, you just have to do DAB start, and for example, specify the configuration file, I don't remember if I configured for running locally or not, but we can give it a try. And basically, it is just running Data API Builder locally. I think now it is will error out because we are increasing our security practice, so I need to avoid to use. Oh, I already did it. So I thought I was still using login and password, but here I'm just using managed identities, so there is nothing with password here, and I can just go here. This is showing me that is running the latest version, so I can go to rest/sessions, and that's the session that I have in my database, right? That's it. That's my database exposed as a REST endpoint. It's running locally. The same behavior will be in the cloud. Now that I know that I can easily expose, so I have basically it is part of my architecture completely done for me. So the client is done. We saw that is React. I just explained how to do the backend with Data API Builder. Now I want to build a database. And the database is very easy. Let me show you. Actually, let me open the real database. Again, it's all public data, so there is nothing kind of secret there. It's just the session at VS Live. So I can go here and zoom in. And in the meantime that this connects, I want to also provide another good article that you can use to start to use vectors right away. If you don't want to wait for kind of using the vector function, you just want to start using vectors today in SQL. I have written several articles on that, and this one is probably the one you want to start from, that explains how you can store vectors in a regular SQL database. And of course, again, we are working on providing native support, but my message as developer is that don't be stopped by things are not natively supported, because you can always build your way around it. This is an example. Okay, so I see a question here. I'll take a look at the link posted before the end of the session, and I will tell you if it's possible or not. I guess so, but I give you a more precise answer. Okay, let me connect to the database. Nice, and so here we go. So this is the session, and so you will see. These are the session of my database, right? The title and the abstract, as usual, other information. I'm starting to update this project to also support embeddings. And as you can see here, the embeddings are saved as the native vector that we support now. But I'm also keeping an eye on making sure that it's compatible with everything. So I can also show you that, let's say, take, for example, session 5. So we can do select start from web.session embeddings, where ID equal 5. And here you will see that instead of storing the vector in a row, I have one row for each dimension of the vector, for each value of my vector, and I have exactly 1536 row, because that's the size of my vector. And thanks to this factor and to the fact that actually cosine distance is nothing more than a simple multiplication and addition, it's very easy to calculate cosine distance manually without using a native function. So that's exactly what I do in my storage procedure. Find session procedure, the one that has been exposed as a REST endpoint via GraphQL, via Data API Builder. And the storage procedure is interesting here for two reasons. So I take the text that is passed as the search text. I use a very interesting storage procedure that we added in Azure SQL and then can be recreated easily in SQL Server using a SQL CLR that allows Azure SQL to call any REST endpoint. And luckily for us, all models are today, or AI models are exposed as a REST endpoint. And specifically here, I'm connecting to my embedding model, so an AI model trained specifically to take concept and turn them into embedding, and calling it from Azure SQL. So it is a REST call from the database. And the result is actually a JSON object that I can convert into a vector. And in this case, again, I'm not using the native vector support for now at the moment. And so I'm just calculating, this is for speakers. Let's go to the session. Oh, I think I started, let's see. Oh yeah, I started, interesting, doing the conversion already. So that's great. Let's focus here. So this is how you can calculate cosine similarity without a specific function. It's very easy. So it's a sum with a multiplication, so not really complicated. But if you instead have the native vector support that we are adding, it's very easy. You can just use vector distance and basically calculate the vector distance as using the vector distance function, which is somewhere here. I don't find it right now, but oh no, so yeah, I haven't. I am not using the vector distance yet. I'm still doing the calculation manually. But either way, it is just to show you that again, you can use vector today. Once we have the vector distance, it will be even easier to use them. So because you have to write, so all this code will actually become vector distance function. So you don't even have to write all this code, but conceptually we'll be doing the same thing. So we have the function, the storage procedure here exposed. To expose the storage procedure, we use the API builder. So what is missing right now is basically the ability to take my data here, yeah, my session here, and make sure that as soon as I change the title or the abstract, or I even add a new one, I recalculate this embedding. And as a test, what I can do is update my session embeddings and actually the column embeddings equal null, where my table set. Okay. Embedding. Embeddings. Okay. Oh, come on. It's name. Oh, that's right. No, this is just session. Sorry. Nice. So now in my session, let's say I'm in the process of converting everything from the classic mode, so using a column store, using the native one. And of course, I want to make sure that my session here has the new vector embedding, but now I deleted it. So how do I automatically make sure that this embedding is calculated whenever someone has deleted it or some changes happen? Well, let's just try to do something like that. Update session set require embeddings update. Require embeddings update equal 1. And let me run this. Now, in a few seconds, you will see the, oops, sorry. In a few seconds, so let me do this again, and let's do a simple select from web.sessions, where equal 5. Let's see if we have the embedding already or not. See? Okay, now it's there. Who put it there? Because I clearly remember I set it to null, and then if I'm quick enough, it's probably, oh, it's already there. Oh man. So what's happening? There is something behind the scene happening, right? That is monitoring my table and is automatically reading the text and the abstract and converting it to an embedding. And the code is in this session processor function. And the part that I'm interested in showing you here is this little attribute. Let's go for the session. Here we go. So What this attribute is doing is saying, even though it's called a SQL trigger, there is no real SQL trigger created on a table, right? So unfortunately, there is a kind of a mismatch in names here, but this SQL trigger is from a Azure function perspective, which means that this table will be monitored, and as soon as there is any change happening in this table, this function will be used. So there is an external process monitoring the table using change tracking, and as soon as something has changed, I have all the changes listed in this list. So I can iterate over all the rows changed. In my case, there was only one row. As long as the row is not deleted, and as long as the column require embeddings update is set to true, so it's different than 0, then I will create a payload for my process changes internal function, and the process changes internal function calls to OpenAI and ask for the embedding. What this code is doing is exactly what this storage procedure is doing, but in C#. So this code here, get embedding async, is basically running what this storage procedure is doing. It's calling my endpoint and calling the embedding model, right? It's just a easier way for a C# developer to call the code without having to worry about making an HTTP call, handling the errors or the retry logic. So it's nicely wrapped up into the embedding async function, and at the end of the day, you get an embedding, and then you can just serialize the embedding and save them and send to my storage procedure that will actually store the embedding. And the storage procedure that stores the embedding is called upsert session embeddings. Let me show it to you. And in this case, is using, since I'm in the process of converting the existing sample to use the new function, is now using this new function called JSON array to vector that will actually take your array, your vector, and save it into a more compact and fast binary format, which is the one that you see here, right? So this is an embedding for us. In fact, I can do embed JSON vector to JSON array of embeddings, and that will be transformed back into the values in a kind of a human readable format. So we've seen pretty much everything. So we have seen the front end, data API builder to expose REST endpoint for storage procedure and tables, the database that can already store vectors today using a single table as a technique, or the new vector type if you want to start to use the new vector type, which is in private preview. And for now, it's only working on Azure SQL. We are deploying on SQLMI. So you need to be on Azure to use the new vector type. That's why I wanted to show you both the option. There is a function that is monitoring the database to check for changes, and the function behind the scenes is just using OpenAI. In this case, I'm using OpenAI in Azure, so you can create your OpenAI model in Azure. But for example, you can use Olama or any other model that supports OpenAI API, and it will work either way. And that's pretty much it. So that's the overall end-to-end. Again, my recommendation is to go to the website here, play a little bit with this, move to the GitHub repository, and clone it, go over all the steps, easily run on your machine. You can even deploy everything using AZD CLI, so it's just one-line deployment in Azure. And of course, the database will be empty at the beginning, so you can start to add some sample data here, and you will see it, how it works behind the scene by adding your sample section and then seeing what happens behind the scenes, seeing the function running, and just seeing how the data move through all the data. Other few things, no, I think I mentioned everything. I mentioned the vector similarity search and the title, the blog post with the early adopter preview if you're interested. So I think I covered pretty much everything. I see, okay, a couple of questions here. Okay, so let's start from the last one. What is a session exactly? A session is just a conference session, right? So if you take a look at the session table, basically is a title with an abstract with a code that starts at a certain time and ends at a certain time, delivered by some speaker. So it's just, you know, in your case could be a class. In my case, it's a table. Actually, it's also a class in my application. Oh yeah, you want the URL? So let me go. Oh, I think I closed it. So ai.chicago.vslide.com. Here you go. Pasting this in the chat. So here you go. And then okay, so let me check at this website. They post so the question is if this sample can be rebuilt with Azure, and absolutely yes, because that's a RAG solution. So yeah, absolutely yes. Everything here looks to me it can be easily done using this sample as a kind of a kickstart, where instead of having a session table as I have here, you have something like a submission table. Or draft decision. So I'm not sure what you are saving here. This decision clerks decision. But yeah, it's. I mean, this is a RAG, so definitely can be basically rebuilt using the sample I have just shared. Absolutely yes. Okay. Let's see if there is any. Okay. Okay. Anything else? Hopefully it was clear. I know it's a lot of content. I will also share the slide deck with Sam. So if you want, you can publish it also, or I will just you know, save it somewhere so it's easy to reach out even via URL. But on my side, I think I covered everything I wanted to cover.
And very nicely done as well. Some very interesting topics that you covered there. Very cool. Wanted to pause for a moment and just ask everyone again, do you have any questions or comments for David? Feel free to come off of mute or enter them into the chat window. And while we're waiting for that, I will post a couple links in the chat window, and we'll cover those in just a little bit. So if there are no questions or comments, David, thank you for a great presentation. Yep. Really useful stuff. I've captured all the links, and I will post them on my blog. So I just have a couple wrap-up announcements before we adjourn for the evening. And so let me go ahead and share my screen. As mentioned earlier, the meeting is being recorded and will be posted on YouTube with the link available there. Just wanted to remind you to please subscribe to get upload notifications. In addition, tech events in the region are also posted on my blog. And again, if you subscribe to that, you'll get automatic updates. And last but not least, the feedback eval form. If you would please take a moment to fill that out, and that will help us to provide David with some constructive criticism, as well as it will be used for the raffle prizes that will be given away. If you have any questions after the meeting, feel free to reach out to me. My email is snasser@nistechnologies.com. You can also find all my social links as well as email on Linktree/Sam Nasser. And lastly, if we're not connected on LinkedIn, I strongly invite you to do so. So feel free to, pardon me. So feel free to either follow me or connect with me. And with that, thanks again to David. Thanks for all the attendees, and we'll see you all at next month's meeting. Good night, everyone.